Okay, we can start, sir.
Yeah, Mfundo, there's some echo on this. Somebody's speaker is on somewhere. Okay. All right. Well, hello everybody, and good day to all of you grade sevens out there, and those of you who have joined us today. Welcome to you. Again, I obviously in the last few days haven't learned anybody's name, so I'm actually not sure if anybody is brand new today. And so if you are, and if you have joined us for the first time, a very warm welcome to you from Africa Teen Geeks. And this is a special holiday program brought to you by them on coding and robotics, a new initiative, and very much soon going to be coming into your schools as a subject that you can choose. I am your facilitator for this week for the holiday classes. My name is Mr. A.F. Gabriel, and I teach information technology in a school in Durban. And I know some of you are from Durban, and some are from other parts of the country. Um, like I think a lot of people from Johannesburg, and it's good to be with you today. And I hope that as we progress, that I can teach you something very short and quick and interesting about how we can write code. Now we're using a program called MS Zora, and I already um, told you how to register. I already told you how you can um, log in. And so, because we are already on our third day and we've only got 2 more days to go, and we are also hoping that some of you would take what we teach you and what you can experiment with yourself. And even if you watch the videos where we did some animation in the early part of the year in January, combine all that knowledge that you learned to create a project for a competition that we'll be holding and some lovely prizes to be won there. Laptop computers, Raspberry Pis, and so on, and that will all be happening in the beginning of the month of May, just almost only just next week. Okay, so here we are, and we are now in MS Zora, and I've pre-written some code for us. Well, what we've already done, but what I did do was I did change the sprite. I had a ball uh, in our previous lessons, and if you look into the screen now, you will find that I have changed it to one of the other characters. It's a little girl, and according to the sprite names, she is called Avery. Say hello to Avery, everybody. Okay, now I'm going to quickly just run the program, and I'm going to run through it again, especially for anyone who might have just joined for the first time. We've got the following set of instructions that we are giving Avery. Remember, you're only in grade 7. This is early code, but I want you to see how you can actually give instructions to something. And when you actually do this job, you will be writing code very much like this to give instructions to a mechanical device referred to as a robot. But for today, Avery is our robot. So, and what Avery is going to do for us is she's going to do some drawing. And we've got a special set of combinations of code for a pen. And obviously for drawing, we must put the pen down, and not to draw, we must pick the pen up. And so pen down, and we clear everything that's on the screen. And then you remember I taught you how to use a loop, and here it is. This is a repeat loop, and it says repeat 3 because we want to draw a triangle, and Avery is going to draw a triangle for us, as you can see there. And we're going to say move 100, turn 120 degrees, and wait 1 second. That's in the loop. But she does that 3 times. But every time she does it, she draws a 100-step line, which is about as long as this, and comes to the end. Now, the reason I changed it from the ball is because when we run this code, you can actually see Avery turn. Unlike the ball, because the ball is round, when a ball turns, we actually won't notice that it's turned. So I decided let's show you how the sprite is actually turning, and you'll see Avery turning on the stage. So let's quickly run this program and let's see how Avery operates. There you go. She's turned 120 degrees. So you saw each time she turned in a different direction, she actually turned 120 degrees from where she was. So you can actually see. But of course, because 120 times 3 is 360 and 360 degrees is a full turn, Avery ends up in exactly the same place that she started in, and that is out here. Okay, so guys, you got all that. Okay, good. Now, I want to say to you guys, I wanted to show you what would happen if we needed to put a second sprite on the screen and have two sprites. So let's click on sprite, and we've got Avery there. That's Avery that I used. Um, let's use this arrow for fun because I want to show you something else about the arrow as well. Right, so I will move the arrow here. So we want to start the code from there. And let's quickly go through it. I'm also going to take this opportunity to just run through each step that we did, right? So the first thing we want to go is we want to go to events and we want to say when the flag is clicked. So the arrow must also run its code when the flag is clicked, right? Okay, then we are going to go to our pen and we are going to say erase everything that's on the board, right? Then we are going to say pen down. Then we're going to use our repeat loop. Remember, repeat loop is in the control structures. I'll remember it yesterday. All the loops got these little white arrows showing up. So that's 1, that's 2, but the repeat loop is this one. And it's got 10 in it. We're going to click there and change it to 3. And then we want to do our move. So we go to motion and it says move 10 steps, but we're going to change that to 100. So 100 steps. Then we're going to do the turn. And just for fun, we've got Avery. Let's go. Can you see I'm on the arrows code, but I can always click to Avery. Avery is turning to the left. So let's make the arrow turn to the right instead. That is this way. Let's see what happens. And we want the arrow to also turn 120 degrees. And we also want to wait 1 second. And we'll put the pen up when the arrow is done. Now, watch what we've got. We've got 2 different codes. One is for Avery, and one is, but it's the same code. And there's our arrow, and there's the code for Avery. And I want you to look at the little watermark in your script area. When you are when Avery is selected, it's showing you that the code you got is for Avery. She will run this code when the flag is clicked. What will the arrow do? The arrow will run this code when the flag is clicked. That's when they'll both start. Now let's run both of those and see what happens. Okay. The arrow, because we said turn to the left, it did 1 turn to the left. And you can see now that both the sprites are actually working at exactly the same time, right? At exactly the same time. I should maybe put the erase in this place, because what actually happened is when Avery's erase kicked in, it erased the line that the arrow drew at the same time. Right, okay, so yeah, that's going to erase that line. Because we've got, in fact, let's take the erase out of the arrow. We don't need the erase in the arrow, since Avery is erasing the screen when she starts. Okay, so let's run our code now. Okay, so there we go. We've got the arrow moving and we've got Avery moving. So you've got 2 sprites doing something at exactly the same time. We are missing one line here because Avery's erase is taking place and erasing that line as soon as the arrow draws it. But no matter, I just wanted to show you how two sprites on the screen can do something at exactly the same time. Okay, now let's take the flag clicked out of there. Now see what I've done there. I separated when the flag is clicked from the arrow. Now let's press go. Now can you see the arrow's code is not running, because even though it is here, it's waiting. It's got no instructions on when to start. We will have to choose a special event to get the arrow to start. The most common one is when the flag is clicked. Okay, so that's how you can use two sprites on the screen at the same time. I've also decided to show you this because, again, for projects, maybe you want to be a little bit fancy, and maybe you want to have more than one sprite working on the screen at the same time. Okay, now we're going to concentrate still a little bit on Avery for the moment. And what we're going to do with her, so we've got the right code clicked, is now I want to teach you the next thing that we want to look into. And that is, we want to look at how to use a variable. Now remember, there was a relationship between the repeat and the number of turns. If it was a three-sided figure, we took 360, we divided it by 3, and that's how we got 120, right? If we want a square, then we will say 4 sides for a square. We take 360, we divide it by 4, it gives us 90. And when you run the code now, you'll find that Avery will turn 4 times, and she will eventually give us a square. That was the situation. Now, we're going to do a cool thing today, right? Today, we're going to find a way in which you're going to communicate with the user. Let's hope that we can get to that by the end of the session, because it's 12:15. But the idea now, if we don't finish today, we should be able to do a little bit of it in tomorrow's lesson. But here's the plan, right, guys? You listen to the plan. The plan is this: we are going to ask the person using the computer, the person running the program. At the moment, it's me, it's you and I, right? That person is called the user. Whoever is running our code, whoever is sitting in front of the computer and watching the triangle and the rectangle, square being drawn, that person is called the user of our program. For short, we just call them the user, right? So we want to communicate with the user for the first time. You notice that when this program, well, the user will click when to start, right? So the user clicks that button, and after that, what are we doing? We're just sitting with our hands folded, and we're just watching Avery go. And she's going, and she's drawing that rectangle. I keep saying rectangle. She keeps drawing that square, and what do we do in the meantime? We're just watching, okay? So this program has no, what we call user interaction. So interacting with the user is pretty cool. And so we want to be able to teach you what we call user interaction. Now, there's 2 things to teach you. Whenever you're talking to the user, firstly, you must always be what we call user friendly. Always be polite, always give clear instructions. When our user is confused, our program is considered to be very poorly designed, because people will leave it. A user will just say, oh, I don't know what's going on in this program, just put it off. So if you want people to buy your programs, and if you want them to be popular and for companies to use them, they must be very user friendly, which means when we want the user to do things, we must give very, very clear instructions. Now, I'm just going to give you one simple place where we can communicate with the user. And of course, we can go to looks for that. And I want you to look at this one. Let me just drag it into our program window. And this one says, say hello for 2 seconds. And that's the reason for the delay to be included in the statement, is because sometimes the block can run so fast and goes to the next instruction that the user won't even see the word hello. So basically what's happening is that we can get Avery to say hello, because this, you'll notice that the sprite that I've got activated here, you can see, is Avery. And so I'm going to give this instruction to Avery, and Avery can follow the instruction. So it's a say block. And with this block, we can get the sprite to say things. How do sprites say things? Let's see what she says. Hello, right? And let's run the code. So I've added just this blue block from the looks, from the appearance. Hello. And then she goes for it. Can you see that? Okay. So maybe under this condition, because it's very untidy and the screen is all thing, let's put our erase there. Let's erase everything first. And so hello is on a clear screen. Can you see that? Now she's saying hello. And can you see that there's a bubble there? Let's make that delay 5 seconds or 6 seconds. Right. She says hello, and it puts the hello in a little cartoon bubble like you get in the comic books. And you can see you can control how long you want that hello to be there. 6 seconds might be very long if you're waiting for the next thing. So I'm going to put it back to 3. I think 3 seconds is okay. And Avery says hello. And then we can add more things. Let's add a second one. Right now, here it is. And in this one, I'm going to say, hello, I will draw a rectangle. So you can click in there and you can type whatever it is you want the sprite to say. And the sprite will say that. Now she will say that for 2 seconds. Let's change that. That's a lot more sentence for the user to read. So let's make that 4 seconds. Let's see. And then we drag that, and we want that to be under the hello. So again, you've got to repeat, you've got to learn how to drag with your mouse, drag the instruction into the correct spot, and then let go, right? And here we are. Now she's going to say, I will draw a rectangle. Now it's not going to draw a rectangle for 4 seconds. This 4 seconds means that that instruction of I will draw a rectangle will be on the screen for 4 seconds. Now let's run the code. Hello. Oh, I will draw a rectangle. And then she starts drawing it. And again, I said rectangle when I should have said square. So let's edit that, because a rectangle is a square, by the way. Yeah, a square is a special type of rectangle, but let's call it a square. Right, let's run that again. Hello, says Avery, I will draw a square. And then after a pause, she starts drawing the square. Now, can you see how we have increased the user friendliness in the program? The user reads it and he knows what's coming. The sprite doesn't just start drawing the square and then the user is left saying, oh, a square. So because you've communicated with the user, you've got the user in a very, very comfortable place. And so they are very aware of what's happening in the program. Okay, so that is one way that we can communicate with the user. But again, still, it's interaction in a way, but not so much where the user can do something, right? So we want to lead you up to a place where the user can actually press some buttons on the computer. But before we do that, I want to teach you one other thing. Again, I remind you, I hope you got your little notebook and you're making some notes, because I'm going to add some things which at this point you might, you can like forget if you're not careful. Okay, I'm going to take you to the operators button, which is red. The operators are all red. Now, what are operators? Operators are mathematical things that we can use to do calculations and to check things. How big are things, right? I'm sure in school, when you do your sums, you're familiar with these things. Your teacher will give you 2 numbers and you must put the greater than sign or the less than sign or the equal to sign, right? But again, you can experiment with these things when we get time. In the 5-day course that we have for you, we don't have too much time to do all that. However, you will find that the operators that I am interested in are these 4. Right, so I've got someone who's raised their hand. I'm actually going to let Zanukushle ask her question right now. Zanukushle, you have a question?
Can you please repeat what are operators?
Okay, no problem. I'm going to do that now. Okay, Zanukushle, thank you for your question. Right, I did say that we're going to use the operators, which is in the red button. Operators are things that we use for maths. You will know, you get familiar with all the operators. They'll become familiar to you if you remember all the things you learned in your math class. Greater than signs, less than signs, equal to signs. Can you see these things here? But I'm looking at these 4 operators. Now in maths, they teach you the 4 basic operations, right? Do we know the 4 basic operations? Somebody can answer on the chat if you like. Who can tell me what the 4 basic operations of math are? I'll give some people a second to type out that there. The basic operations of math are. Okay, I've got Jordan in the studio with me, and we'll let Jordan answer the question loudly. Jordan. Adding. Subtraction. Multiplication. And division, right? So those are the 4 operations I know by grade 7 you would have used those all the time. Now I want all of you to take a look at our operator screen here. The red blocks. We've got 4 red blocks. We've got addition. Can you see this one? There's a plus sign there. I know it's a bit small, but that's your plus sign. That's your subtraction sign. Now here, that's very small, I think, but it's actually not a multiplication sign. It's a star. It's an asterisk. That is because in coding we do not use a multiplication sign that you know in math to multiply things, because it often gets confused with the X symbol on the keyboard. You see, in math class you write your X as a cursive X, so it doesn't look so pointy. But on a computer keyboard, if you look at the X on your keyboard right now, you can see that it actually looks like a multiplication sign. So for coding, and in all languages, not just Mozilla blocks, but any coding language does not use an X-looking thing that you know as multiplication. They always use the asterisk, which is also, you can also say star. It's a star. Where will you find the asterisk? It's on number 8 on your keyboard, the 8 button. It's sharing the 8 button on your keyboard. That's your asterisk. But you don't have to worry about that because it's already in the block. You see? Then let's look at the 4th one. Also, you'll find that on your computer keyboard, there's no division sign. There isn't a division symbol that you know from mathematics. And so we do not use that. We use the forward slash, which is this slash symbol here. And you can find the forward slash on most keyboards. It's to the left of the shift button on the right hand side of your keyboard. There's 2 shift buttons. There's one on the left and one on the right. If you look for the shift button, the button immediately to the left of the shift button is your forward slash. It is sharing a key with the question mark. So you can find it there sharing with the question mark. But again, you don't need to do that because the operator has got that in there. Okay, so we want to use this one of these operators. What are we going to do? We need the division, right? We're going to use the division, right? And I'm going to drag this into the window, right? So can you see this division symbol? It's showing us 2 blank spaces because we're going to divide 2 numbers. I just saw some responses on the chat from Nur Mohammed on the 4 basic operations, correct? And also Moletsi, thank you for your responses, guys. You are also correct. Division, addition, subtraction, multiplication. Now, can you see this division symbol? Can you see this oval shaped thing? Now, here's where coding with MS Word becomes really cool, really nice, really exciting, because I said it's like Lego. You can fit the symbol into any space in your code that has an oval section, right? Which means you can put it there, because can you see? Say hello is an oval section. You can have it put it there, right? You can put it there in the move button or in the turn or in the wait, right? So your weight can eventually be the result of 2 things that are getting divided, right? Obviously, where you want to put it has everything to do with what you are trying to achieve. So using it can be very complex. And again, we don't have time for complexity in this very short course. But what we are going to do is we're going to put it there in the turn, right, section, because that's where we want to control how many degrees that it would turn. And instead of putting 120, I'm going to put 360 there. And then I'm going to put, oops, code is running. And then I'm going to put 4 there. Okay. Now, let's run the code and see what Avery does, right? Let's run the code. She says, hello. She says, I will draw a square, and she then proceeds to draw a square. Now, the code that we have, look at it very carefully, is exactly the same. Well, the code is different, sorry. The code is different, but Avery is still doing the same thing. She is still drawing the square. Now, who can tell me on the chat, what do you think we did differently? Okay, the one thing, look at the code that we've got in there, and what's the new thing that we've put in? Right. Nur Mohammed, we made the degree more complicated. Sibongoke, we use division. Sadal?
We just, instead of writing the exact number, we actually wrote the sum of division to work out the number of degrees we're supposed to put.
Right. Very good. Now, thank you for your comment, Nur Mohammed. We made the degrees more complicated. It should have been 120. Yes, it might seem more complicated, and very often code that looks complicated is that way because we want to increase our flexibility. We want to increase our flexibility, but I can't. That's why I said I'm hoping to be able to tie it all up together by the end of today. But it looks good. It looks like we got some time. So we're saying 360 divided by 4, and Avery still draws the square. Okay. So now let's put 5 there, right? And then we'll say 360 divided by 5, right? And then let's see what Avery draws. Hello. Oh, but that's obviously not going to be a square now. So we'll have to change that. But she is drawing the hexagon, right? And it's a 5-sided hexagon. If I move Avery out of the way, you can see it's a pretty much perfect hexagon. So remember yesterday we were sitting and sitting with our calculators and we were trying to find the correct number to divide. Okay, but now we don't have to do the division. I couldn't do this yesterday because it would have been too much for you. But now the cool thing is the computer is doing the division for us. And why not? It's a computer. We shouldn't have to divide in our heads and put the things there. Right, it doesn't make sense for Avery to say, I am drawing a square and then draw a hexagon. I think that's a bit funny. So let's just say for now, I will draw a shape because we're just experimenting still with this division. Now, let's go to the next shape. The next shape is a 6-sided shape. So repeat 6 for 6 sides. And then for the degrees for turning, we'll say 360 divided by 6. And now let's give Avery a go. Hello? I will draw a shape. Makes more sense now. And now she's going to draw a 6-sided closed shape, which we asked you on the chat yesterday, and it was there is your hexagon. There is your hexagon. Okay, this delay is too long for the shape. I'm just going to put 2 seconds there. And let's now draw a 7-sided shape. 7. And now, can you see that the work for us is simple? We just have to say divide 360 divided by 7, and that's going to happen. The computer's going to do it for us. No worries about the calculation. Right. And 7, I think, was the shape that didn't have an exact. If you take 360 divided by 7 on your calculator, unlike all the others that we've done so far, it is not an exact result. It's a decimal result, right? And you couldn't put a decimal into the turn. The turn degree thing doesn't. You can't punch in a decimal value there. So the only way we could have drawn the 7-sided shape was by doing division by 7. And of course, we can keep going. Let's go to 8 and 9 because I gave you a challenge yesterday and I'm going to tie up the challenge tomorrow. But now we've got this code which can draw any of the shapes. Hello? I will draw a shape, and this time it's an 8-sided shape. And of course, that is your perfect 8-sided shape, which is known as an octagon. And let's draw one more 9-sided shape. And now we go 360 divided by 9. And let's see what this 9-sided shape looks like. Look at that, goes all the way there. It's pretty big now. That's why I had to bring Avery all the way to the bottom of the screen. So you can see the shapes get pretty much, I think that's okay. That's very much fitting on the stage. That's kind of okay. And so can you see how that operator, the division operator, works now to be able to control the repeat function? Okay, if you want to make the stage smaller for more of your code, and forgot to show you that yesterday, you can click on this little button here and you'll have a very small stage, and sometimes the code gets very long. This is the middle size stage, and this one is only the stage. Watch what happens when I click on that. I click there and I click on that button, and it actually puts the stage on your entire screen now. So that's what you want to, that's generally what you do in the end when your program is finally ready to be working, and that's all that you want to see on the screen. So now your entire stage is the screen. When you want to get back to your coding, you simply close the stage by pressing that button there, and you've got your code all back again. Okay, and that are the operators. Now, I only needed the division operator for this program, but there is the multiplication, the subtraction, and the addition, and I want you to experiment with those on your own. Write code that uses it and see what happens. Okay, now again, at this point, I'm going to pause and I will allow anyone to ask questions. You can actually ask a question by raising your hand. I will let you physically speak before we go to the next stage of our program. Is everybody happy? Everybody okay? And can we move to the next stage? We all okay? We're all learning well? Great. Okay then. So let's move to the next set of instructions. What are we going to do next? Now, as I said to you, I want to take you to a point where you can interact with the user. And we're going to do this cool thing. We're going to ask the user, what shape would you like us to draw? And you can see we will draw the user's choice of shape. Okay, so how do we ask the user any questions, right? How do we do that? And also, how are we going to store what the user wants us to draw? Okay, now to do that, I'm going to first have to introduce you to a thing called a variable. I'm just looking for something. Okay, let me introduce you to how we use something called a variable, right? Okay, now we are going to then go to the section here called a variable, right? Okay, now this one you've got to be very careful. What is a variable, right? What is a variable? A variable is something that we can use to store a value. That's what a variable. I don't think that you are very much clear with working with variables in maths. So you haven't got to that stage yet. I think somewhere along grade 7, you will start using a variable in your maths classes. And that gets more involved when you get to grade 8 and grade 9, right? So let me teach you what a variable is from a programming perspective, from writing code, right? Okay, so first let's click on the variables section of our code. And here we are going to select a variable and make a variable in the program. Now, what is a variable? A variable is a special place where we can actually store a value. We can store a value in the memory of the computer, right? So these are the variable things that we can do with a variable. We can set a variable's value. We can change a variable's value. We can show the variable on screen to the user. And of course, we can hide a variable, right? But we don't have any variable at the moment, right? There is a preset thing they call my variable. We generally don't use that one. We make our own variable, right? So if you've got your notes, I'm going to take you to the process where you're going to make your own variable. How do we make a variable? Okay, firstly, follow the steps. We click on the button. First, you must find the variables section by clicking on this slightly lighter red section of code here. So you've got operators, which is dark red, then variables, which are light. And you click on make a variable. Okay, step one. So you click on make a variable. All right. Then we make a new variable and it wants the name of the variable, right? Now this variable is going to tell us how many sides the shape has. How many sides does the shape have? And our shape, well, you know, the one we've got in the screen has 8 sides, but let's call this variable sides. Now we give the variable a name, so we type it in. So can you see? You've typed this in. Now this variable is going to actually store the information which tells us how many sides our shape has. So we're going to call it sides. The name of your variable must always be something to do with what the variable is doing. We don't want to call our variable by your name. If your name is Jordan, we don't want to call the variable Jordan, because when we see the variable there, we don't know what it means. It's somebody's name. The variable must have meaning. So if it is, in this case, keeping or storing the number of sides of the shape, then we will call this variable sides, and that's a good name for the variable. So let's call it sides. Let's click OK and let's see what happens. Right now, if you look on the left-hand side of the screen, you will see that the variable sides has been created. It's there in an oval shape, and that now is our variable. Okay, now we are going to set this variable's value, and I'm going to take a set instruction. And for the first time in our code, we're going to have some red instructions. Okay, we can set this variable's instruction just before the loop starts, because at that point, that's right here, I choose and I click, and I want to set the variable. Now it's saying my variable, right? Set my variable. If you can see a little arrow there, if you click on the arrow, it gives you a list of all the variables that you can choose. This is not a variable name. This is if you're not happy with the name and you want to change it, you can change it there. And if you've decided that you've made a mistake with this variable or you don't need it anymore, you can click there to delete it. The variable that we want here is the one that we created. It's called sides. And so I want to click on sides. So I click on it. It says set sides to, and of course, it's set to 0. So let's change that and let's say 5. Okay. So it now says set the variable to 5. Okay. And then we're going to say repeat. Now, can you see this oval shape there? Can you see also that variables are oval shaped? Which means that this can fit into that. Remember, any oval shape can fit into any other oval white space. All these empty spaces are actually white with writing in. Can you see they're white? So the oval can fit anywhere in there. So we're now making use of this variable called size. And we're going to say size, right? And it says repeat sides. Now what that means is, before we had repeat and we chose how many sides our variable, our shape was supposed to have. But now we are saying preset it to whatever number you want, and then put that number in the repeat loop. So if it's set to 5, the variable sides will have 5 in the memory, and it will then run the loop that many times. This repeat loop will run 5 times. Now I also want you to have a little peek into the window here, and you will see that the computer is also showing you your variable. It's keeping track of your variable, so you can see it on the screen, right? And you can see what happens to it as the program progresses, right? Ours will be 5. Now, can you see here where we're saying 360 divided by 9? We can also put side there. And now the division is based entirely on this one variable called side. Now remember before, when we changed the number of sides the shape has to, I had to change it there, and then I had to go and change the division. Now I don't have to do that. I only have to change it in this one place here, and then the variable side is now 5, and so the repeat will do 5 times, and this one at the same time will do 360 divided by 5, because the variable side has 5 stored in it. Who put 5 there? We put it. That's in our code. Now let's run the code. Hello, I will draw a shape. And she draws a 5-sided shape because we had set the number of sides to 5. Okay. Now let's go to this one instruction where we now are can you see what this red instruction is doing? It's now controlling the sides. It will it's showing you it's controlling, sorry, how many sides the shape has that we want to draw. So let's now change it to 8. And now let's run the program. And she draws an 8-sided shape. Look at that. Okay. So let's get a little adventurous. Let's see what 11-sided shape would look like if we had to draw one. It's going to be really big though. Oh, it won't be clearly drawn there because we went off the screen. She had to, can you see? That's not clear. Right, big shapes obviously are going to take a lot more space because there's a lot more sides. So perhaps, and now what you're learning is how to actually adjust code to work with the amount of space that you have available. Maybe 100 steps is too big for that shape. So let's drop that to 80. And so you can say, I just click in the button and then drop it to 80. And now let her draw it at that size. I also moved her from the spot. Okay. I also, I remember yesterday I said to you, the sprite will always start wherever you draw her from, right? So I remember whenever the sprite goes off the screen, the X and Y values go off. So that's why our shape is not clear. We needed to start very much from the bottom of the screen. So what we will do is, let's add a little goto. We used goto yesterday. Let's say, let us start as much at the bottom. I'm actually putting it there to see what the values are. Let's put a little bit more to the right. Maybe there's okay. So I'm looking at an X value of minus 102. So let's use minus 100. And let's find that little go to section. Oh, my mouse is stuck. Okay. Let's use the go-to part of the code, which was here, and let's send it to this position to start with. Let's go there first. Go straight to that position and then draw the shape. Right? So let's run the code one more time. Hello. I will draw a shape. So that's 80. And that still manages to fit in on the screen. So we got a nice shape there. There we go. And if we take every out the way, you'll see that's a completely well 11-sided shape. Isn't that interesting? Okay. Now I'm going to pause again, and I'm going to allow for anybody to ask any questions that you might have. I am. If you want to ask a question, you can raise your hand. You don't have to ask it in the chat. This is a question and answer session that I'm allowing you to actually interact. If you'd like to ask a actual physical question, please do so, no problem. Jordan has a question. Okay, Jordan, what is your question?
How come when there was two sprites with the arrow and that other sprite, how come the arrow couldn't complete it and the line got erased? How do we prevent that?
Well, we have to sort away our code in our erase section is not quite what it should be. So I did say that Avery had an erase instruction in her code, and it erased the first line that the arrow drew. So that's why that happened. All right, so there are no questions. Oh, Sibong, I'm not quite getting your name right. I do apologize. Sibonga, can you pronounce your name for me?
Sibonga Konke.
Sibonga Konke. Right. Hello, Sibonga Konke. You are with us and you have a question?
Yes. Why do we have to repeat the sides?
Why do we have to repeat the sides?
Yes, I see there's a function that says we have to repeat sides. Why?
Yes. Oh, you want to know about the variable why we're using sides?
Yes.
Did you understand it when we had a number in there and the number was 5 or 6 and you knew why we had to have 5 or 6 there?
Not really. Can you explain?
Okay. Were you with us yesterday?
Yes.
Okay. I'll explain that again quickly for you. Thank you for your question. Right. We appreciate your question. Let's quickly have a look at why and how this repeat function is working, right? Firstly, what we are doing is we are getting the sprite to draw a shape of a certain number of sides. You can see that we've got this program up to a point now where the sprite can draw any shape of any number of sides. First, we started with 3 and 4 and whatever it was, and we wrote the code. Then, if you remember on Tuesday's lesson, we introduced how you can use a repeat instruction so that we don't have to keep writing move, and here's our move instruction, turn, and wait 1 second. What are these 3 instructions doing, kids? It's drawing a side for the shape for us. Move 80 steps. It moves 80 steps, but if you look up here, you'll see that the pen is down, which means when it moves 80 steps, it is going to draw a line. It's going to draw those steps as it's going. Then we want the sprite to turn, okay? But the turn is based on what size the sprite is. What is the size of the sprite? And I'm sorry, not the size of how many sides our shape has. So if our shape is 3, we take 360 degrees, we divide it by 3, and that's how we work out how many turns, how to turn the sprite. Remember, it's 360 because we want the sprite to always end up in the same place that it started. Why? Because we want to close the shape. Right, let's watch the shape on the screen. First, the sprite's going to go there, then turn, then go there, and keep doing this. So the turn is actually based on 360 divided by the number of sides, so that eventually she goes 360. Remember, 360 degrees is a full revolution. It means that the sprite's going to come back to exactly the same spot that she started. So that is why we are taking 360 degrees and we're dividing by the number of sides that the shape has. Finally, what we've done today, and now again, to the student who just asked the question, we introduced a variable into the program because we want to make the program much more flexible and much more powerful. Remember, we're leading up to the point where we're going to ask the user how many sides does he want his shape to have. Now, this one is not asking the user, we are presetting it. See, there's this red instruction at this point that says, set the number of sides to be 11. Now, what this variable is doing is it's actually keeping track of how many sides our shape has. Right? And of course, at the moment, we are changing it. But tomorrow, and I can see we have run out of time, but tomorrow the user is going to get a chance to do this. We're going to ask the user, how many sides would you like? And can you see now, you can draw a shape that has exactly the same number of sides that the user would want. Okay, so that's what this variable does. So we can change it anytime we want. So that's why the repeat loop, remember the repeat loop was always had the number there that number represented how many sides our shape has. Since the variable side is actually storing that number, we put side there. Now your question was, why did we put sides in the repeat loop? The answer is because the variable sides, that's this red thing here, is actually storing for us how many sides our shape has. So that's why we're repeating sides, because that's how many sides it must draw. Then here, because we don't know how many sides the user might choose, we don't say divide by 5 or divide by 6 or put a number there. We divide by a variable, which of course again is called sides. So if the user, and let's change it, we put 11 there, right? Let's just change it again to 5. Right now, the sides is 5. Can you see I put 5 there, which means this becomes 5. It will say repeat, not side, but 5. And then it's going to take 360 and divide by 5. So a variable, if that might be confusing you, is something that can keep changing. And we change it in this one red spot here, where we said set side to 5. So if I click there, again, I can change 5 to 6 and then run the program. And now side is 6. So when it goes here, it puts 6. So can you see the idea behind a variable is so that we can change its value. If we change the value, then everywhere the computer sees side, it knows that it's 6 because it's set in this instruction. Right now, let's watch the sprite draw because we changed side to 6. It is now going to draw a 6-sided figure. Hello, I will draw a shape. And now, of course, she is drawing a 6-sided figure. Okay. Right. And look, that's as much as we have time for at this moment in time. I'm going to save this program. We'll use it again tomorrow. Let's again call it, draw shape. right? And I want to save it to the cloud. So I click on save, and you can see also after you save something, you put the little tick there to say that it's saved. So our program is saved. Tomorrow we're going to come back. We're going to make it all the more exciting because we're going to get the user to also interact with our program, and the user will be able to choose how many sides the shape should have, and that would be very interesting when we get the user to control it. But yes, variables, for those of you who are trying to get your head around this red code, again, not very straightforward stuff to work with. But what I want you to do is have a look at this code after this lesson is over, and just look at the red bits. And I want you to see how important the colors all are, right? Remember, you can see your loop because the loop is this mustardy color, and you can see where it's controlling. It's starting here, it's ending here, and it's repeating those three things. Now we've added a variable to it, and now the size of the shape is completely and entirely dependent and controlled by the variable. So fiddle around with this thing and see what it does. Okay, so to recap, we've got this go to, which can send the sprite anywhere. We've got the pen, which is the green stuff that we can draw stuff when we put the pen down. We also included comments like the say instruction so that sprites can actually talk to the user. And of course, lastly, I introduced you to the variable. That's as much as we will be doing this week. We will not introduce, if you're feeling that it's a bit much and it's a bit confusing, it'll be a little clearer tomorrow because we'll spend a little bit more time on the same stuff. And I'm not going to introduce anything new today and nothing new tomorrow. We're just going to experiment with the code that you see on your screen now. We're going to use the same things. We'll make the code a little bit bigger. We'll draw more stuff. And in fact, tomorrow I want to try and draw a star for you, a 5-pointed star. And I want to show you how you can actually change that to a 6-pointed star and how the user can control that as well. Okay. Before I sign off, and I have 2 minutes left, I want to say this to you guys. There is lots of things happening over the holiday period with Africa Teen Geeks. Remember that we've got some workshops happening, and what the workshops are going to be doing is that they're going to show you a little bit more about how we could develop apps. And we've got some really, very special guest speakers that are going to be talking to us. And you might want to join, and I encourage you to join, because one of the things you'll be able to find is you can see as a career, as a programmer, where this is going to take you, what you can do with it. And maybe you might want to, you're only in grade 7 and you never know, maybe you're not sure whether this is for you, is it not for you. If you attend that workshop, you'll be able to interact with the speaker, actually ask what they probably will have a question and answer section where you can ask them anything you'd like. And maybe that workshop might help you see how applications are developed and whether or not you might want to choose the right subjects when you get to high school that will want to allow you to enter this field for your career. So that's happening at 4 o'clock every day, and there's one today. And if you go to the Africa Teen Geeks website, that's africateengeeks.co.za, you will see that there is a link to that developer workshop. It's also free, and you can join up, and that's happening at 4 o'clock. With that, children, I want to say goodbye to you. If I don't have any more time to take any more questions. Sibogankonke, I see you have your hand up. I will just let you ask your question before we sign off. We kind of have 1 minute left there. So let me see if I can get you to. Okay. Sibonga Konke, you are live with us again. You can ask your question? Hello, Sibonga. Okay, I think we've lost Sibonga. Okay, guys, I'm out of time. I'm very happy if you have any questions. What I will do is, if you do have one, write it down, save it, keep it. And what I will do is, I will allow you to ask it in tomorrow's lesson. I'll put some time in for the questions, even if you have questions about this code. In the meantime, I think you've got quite a lot of work to do to browse through this program, see how it works, see what's happening, and maybe tomorrow we can do a little bit more and improve it a little bit more. Otherwise, thank you very much for sharing with me, for joining with me. Have a wonderful day, kids. Do experiment with the programs, and I will see you tomorrow, same time, 12 o'clock. I couldn't hear him.